All right, hello again, pre-calculus people. So today we're going to be talking about doing some solving of quadratics. Again, not really a pre-calculus topic, but something that a little different method than maybe you saw back in algebra. So past couple of days we've been doing this complete the square thing, right? To find the vertex of a quadratic algebraically. And one of the problems we had on that last assignment was like this, right? So we did complete the square. We got it to be x minus 5 quantity squared minus 6. So we found the vertex. But what if I use that same problem, that same equation, and I said, can you find the solutions to that quadratic? And remember, solutions, also called x-intercepts or roots or zeros, where it's crossing the x-axis, right? Well, if I gave you that, you'd be like, oh, well, hold on, I can just factor that. But this cannot be factored, right? Because obviously nothing multiplies to 19, that'll add to be negative 10. So you're like, well, I can't factor it. How am I going to find the zeros? Now, some of you may know something that you did in Algebra 2 that would help solve this, but if you have vertex form, we can actually find the zeros right from here. And that's what we're going to be talking about today. Okay? So remember, whenever we find the solutions or the x-intercepts, we're just going to set what we have equal to 0. Well, since this was equal to my initial problem, I can just do that. Okay? And now it is just an algebra. You got to do some algebra to get x by itself. Okay? And remember, what we do every single time right off the bat, we need to isolate the squared term before we get rid of that. So the first thing we got to do is add 6 to both sides. So we do x minus 5 squared equals positive 6. And then we can undo the square part of that by taking the square root of both sides. So we'll do the square root here and the square root there. So that just becomes x minus 5. Now, when you do the square root, again, remember previously, anytime we talk about a square root, we do talk about the plus or minus. Remember, if I said, like, what is the square root of 4? You would always tell me it would be plus or minus 2. So we're going to use a plus minus symbol on all of these things. So plus or minus root 6. And then we continue getting x by itself. Just add 5 to both sides. Now, when we add 5 here, remember, we can't combine these things because that 6 is inside the radical. So it's not that. Traditionally, we put that constant before the radical. You can write it after, but then it might be kind of confusing to see what number's underneath, what number's not underneath. So we usually put this constant that you add or subtract on the outside before the radical. So I'm going to write that as 5 plus or minus root 6. And that's going to be my answer. You do not need to get a calculator and see what that is decimal-wise. Nobody cares, least of all me. And literally, that is the exact answer. If you got a calculator, it'll be some kind of weird decimal. Any decimal approximation is an approximation. It's not the exact answer. This is exact. Okay? So that's what you do, right? So anytime you have vertex form, and you can always find vertex form by completing the square, then you can find your solutions as well. Now, what we're going to find a little bit later on is we can use complete the square to find still another way that we can find the zeros from standard form. And we're going to see that tomorrow. Okay, so I got 2 more examples here. I know I just did one example, but why don't you, how about if you haven't gone through this yet with me in class, how about if you pause the video real quick and see if you do that same process for these 2 questions. Again, find the zeros, and then I'll zip through the answers pretty quickly here. Okay, so on the first one, again, remember, we always want to isolate. So we're going to add the 17 to both sides. Got it by itself, so we can do the square root of both sides. And remember, always use the plus minus. And then subtract 4. So x equals -4 plus minus root 17. And that is it. Remember, and that does say two different solutions. So like one solution is -4 plus root 17, and then the other one is -4 minus root 17. So that's where but that plus minus notation is just kind of a shorthand to get both of them done at one time. And then how about the next one? Again, isolate. Square root. But notice in this case, the square root of 25 is just 5. So in this case, I can clean that up, right? So I can say it's either plus or minus 5. But look, if it's a normal number, I can go and do my two solutions. I don't need the plus minus anymore. So I can say 2x minus 1 equals positive 5, or 2x minus 1 equals -5. And then just solve both of those and get x by itself. So add 1 to both sides. You got 2x equals 6, x equals 3. Add 1 here, 2x equals -4, x equals -2. What that actually tells you, ladies and gentlemen, what that actually tells you is that your initial, like if you had this in standard form, you would have been able to factor it to find the solutions. But this is what your vertex form is. Okay, so if the square root comes out to be a nice clean number, might as well simplify it and solve it from there. If it's any kind of radical, leave it as a radical and it's fine. Okay. One more example, then we're going to get into a couple cases that we won't really get into for a couple more days. But take a look at this one, and again, if you want to pause the video and work through that on your own. So remember, we need to isolate first. So I need to get that thing by itself. In this case, we actually got to get rid of two things. So I definitely want to add 8 first. But now I have to divide by 3, and I got to get rid of everything before I take the square root. So now it's just x plus 2 squared equals 8 over 3. Now when you do the square root, make sure you're doing the square root of the whole fraction. So it's x plus 2 equals, always plus minus, 8 over 3. And then we can subtract 2 from both sides. So x equals -2 plus minus root 8 over 3. Now, depending on who your teacher is, they may want you to simplify that a little bit more. I am personally just not too worried about it. In these days, this is mathematically equivalent, and even like the cleaned up answer isn't going to be much cleaner than that. So this is 100% okay with me, again, and it's mathematically equivalent, so it's okay. If your teacher says, well, we should rationalize the denominator, you can come to me and I'll show you how to do that too. But again, I just don't think it's terribly important, at least until later on. Now, the one thing you might have noticed is on all of these examples, the thing I moved first, that constant, all of these were negative numbers, so they became positive when I put them on the other side. That will clearly not always happen. Okay, so we got 2 more examples. But look, we still do the same thing, right? We still isolate. So I'm going to subtract 21. Divide by 7. And that's obviously just going to be -3. Whoops. Square root. Now, already you might be saying, well, hold on a minute here. You can't take the square root of -3. You're right, but I'm going to keep on going. I'm going to go and get what it would look like anyway. So we got x equals +9 plus or minus square root of -3. Now, those of you that remember your algebra 2, you may remember something called I. And there is a way that we can simplify that. But for today, at least for the next couple of days, if you see a negative inside the radical, if you see any kind of negative number inside of a square root, you're just going to write no real solutions. This does have solutions. It has imaginary or complex solutions, but that's how we're going to kind of deal with that right now. Okay. So again, in a couple of days, we're going to be re-talking about I. If you remember, that's square root of -1. But again, we'll do that a little bit later on. Okay. Last example. Again, pause the video one more time. See if you can figure out what that is. And we'll finish that up. So remember, isolate. Subtract 5 from both sides. How do you get rid of a fraction? Multiply by the reciprocal. So 2/1. Let's equal to -10. Square root both sides. And then subtract 3. And again, for our purposes today, that is, write the solution like that, do the work, show all those steps, but then you can just say no real solutions. Okay? So that is solving from vertex form. Isolate the square, take the square root, you always do plus minus, get x by itself, and that is it. Tomorrow we'll look at the quadratic formula, where that comes from, and continue on with complex numbers. Until next time, stay safe.